Now, let us take an example of a cubic which is not factorized. So, y is equal to 2x cube minus x square minus 4x plus 10. So, whenever a cubic is given in this form, obviously you cannot factorize it directly, because if you try x equal to 1, minus 1, 2, minus 2, so on, none of the values of x work and give y is equal to 0. So you don't have zeros for this polynomial. Now how do you draw the graph of this? So whenever you have polynomials like this, we use the concept of maxima and minima. So first try to find dy by dx is equal to 6x square minus 2x minus 4. So equated to 0. So let us say that the differentiation of this is equal to 0. So let us see whether this can be factorized or not. That means we are trying to find whether there are the values of x where you get maxima and minima. So is this quadratic easily factorizable? So this implies if you take a 2 outside, it is 3x square minus x minus 2 is equal to 0. 3x square minus 3x plus 2x minus 2 is equal to 0. 3x times x minus 1 plus 2 times x minus 1 is equal to 0. So x minus 1 times 3x plus 2 is equal to 0. So this implies x is equal to 1 or minus 2 by 3. So these are the points of maxima or minima. So now if you draw the graph of this. So first let us try to find these points. X is equal to 1 and x is equal to something like minus 2 by 3. Now we know that the graph starts from the top because the leading coefficient is positive. So obviously it has to come down. And you have a minima at 1 and you have a maxima at minus 2 by 3. So you cannot have a maxima at minus 2 by 3 and minima at 1 and minima at minus 2 by 3. So if the leading coefficient is positive, it starts from here. So you have to have a minima first and a maxima next. And what is the maximum and minimum values? You put x is equal to 1. So y at x is equal to 1 is equal to 2 minus 1 minus 4 plus 10. So 10 minus 5 is 5 plus 2 is 7. It is at x is equal to 1, the value of y is 7. It's a positive value. And when x is equal to minus 2 by 3, so let us find the approximate value. So what is the value of y at minus 2 by 3? Is equal to 2 into minus 8 by 27 minus 4 by 9 minus of 4 into minus 2 by 3 is plus 8 by 3 plus 10. So clearly this is a positive value. Which is more than the value of 7. Because if it's a minima, you have to go up. So if you try to find this, you get somewhere around 9 or something. So you have at minus 2 by 3, you have a value of 9. Something around this point. So now here you have a minima, hence the graph has to be like this. Here you have a maxima, hence the graph has to be like this. And if you connect everything, it starts from above, it has a minima here, it has a maxima here, and then it goes down. It doesn't have any more maxima or minima, so it has to go down from this. So this is how the graph of 2x cube minus x square minus 4x plus 10 looks like. So what did we do here? We have found the points of maxima and minima. We have found the values. We have found that both are positive. Hence the graph has to turn completely above x-axis and it has to come down like this. So whenever you have a cubic, it starts from one end, it has to come down to the other end. Because when x is plus infinity, y is plus infinity. When x is minus infinity, y is minus infinity. So how many roots does this equation have? This equation has only one real root and two imaginary roots. How did we find that? because the graph cuts x-axis at only one point. So using the analysis of graphs for a general cubic equation, we can find the number of real roots. So I hope this process is clear. Next, let us go for higher degree polynomials and see what we can do for those graphs.